Relative atomic masses. So the standard used by scientists to compare units of atomic mass is the carbon-12 atom, which has been arbitrarily assigned a mass of exactly 12 atomic mass units, or 12 AMU. So one atomic mass unit, or 1 AMU, is exactly 1/12 the mass of a carbon-12 atom. The atomic mass of any atom is determined by comparing it with the mass of the carbon-12 atom. So the average atomic mass is the weighted average of the atomic masses of the naturally occurring isotopes of an element. Now, calculating average atomic mass. The average atomic mass of an element depends on both the mass and the relative abundance of each of the element's isotopes. Okay, and the best way to understand this is do an example problem. So it says element X has two naturally occurring isotopes. The isotope with a mass of 12.012 AMU and 10X has a relative abundance of 19.91%. The isotope with a mass of 11.009 AMU, 11X, has a relative abundance of 80.09%. Calculate the atomic mass of element X. So this is what we're going to do, right? Our final units are going to be AMU. So we're going to have the mass. I'll put I1 for isotope 1. We're going to multiply that by the relative abundance. So I'll say rel A of isotope 1. And I'll write this out because I think we're going to get confused by looking at all these symbols. So, once again, our final unit's going to be AMU. So equals, okay, we're going to have the mass of isotope 1 multiplied by the relative abundance of isotope 1 plus the mass of isotope 2 times the relative abundance of isotope 2. Now, this can keep going on as for how many isotopes you have. You could have 20 isotopes. It could be times the mass of isotope 20 times the relative abundance of isotope 20, but usually 3 or 4, probably the most you see. Okay, so let's plug our numbers in here. So 10x here, so our mass, our first isotope, is 10.012. We're going to multiply that by 19.91%. But here's the thing. When we plug that relative abundance in, we need to change that to a decimal. So it'll be 0.1991 plus 11.009 times 0.8009, because remember, we're going to change that relative abundance to a percent. Or sorry, to a decimal. So 10.012 times 0.1991, and we get 1.993 plus 11.009 times 0.8009, and we get 8.817. So if I add these numbers up, I get 10.81 AMU. So remember, when you're plugging your relative abundance into the equation, you need to change that percentage to a decimal. And this concludes our video on average atomic mass of elements.